Hello, my name is Catherine Nguyen. I'm a student at Old Dominion University, and I'm completing a series of demonstration videos for microcontrollers and embedded-based designs as part of my senior project. In this video, I will demonstrate the operation of labs number 3 and 4, 4x4 matrix keypad exercises with PIC C AdvT This lab utilizes the built-in LEDs and keypad connections to scan and decode the included 4x4 keypad. How the columns and rows are connected may be subject to change. Also, the LED outputs associated with the individual keys may be assigned on an individual basis. Up on the screen, I have the basic keypad schematic provided in the lab documentation. The connections between N0 and N7 and the PIC inputs and outputs may be assigned, but the general procedure is the same. For reference, here is a graphic created to depict the desired response of the LEDs to the key presses. I have used this table in conjunction with the lab documents and sample programs to create my final program. I will place this graphic back on the screen during demo so it is easy to follow along. Note that I have assigned the uppermost LED, LED 3, to be my LSB. This is reflected in my graphic and wiring. For simplicity, the binary equivalent of the face value of the key is generally used to represent it where possible. Both the keypad and LEDs are implemented on the trainer board, so all that is required is to add the appropriate jumpers between the correct terminals. For wiring, first double-check that your switches, namely S1 and S4, are configured correctly based on the number of pins on the PIC you are using. Reference the appropriate manual for the revision of the trainer board you are using if needed. I'm using the 16F877A with a Rev 3 trainer board and have S1 1 to 5 on and 6 to 10 off. For S4, I have 1 on and 2 off. Oscillator connections are required for this lab. The connectors share a terminal with port E for this PIC and are connected directly to the oscillator circuit implemented on the trainer board via SV4. The keypad will need to be inserted into SV2, shown hatched in blue here. Connections need to be made from the X4 terminals to PIC I/O. In this case, 8 lines from port B are used to scan and debounce the 4x4 matrix keypad. The LEDs can be connected from X6 to the appropriate terminal. Here I'm using port A. Double-check the orientation of the connectors, as the location of the LSB relative to the other LEDs is important for verifying proper operation. Note that a pull-up resistor is needed from pin 4 of port A. I have connected a 10K resistor between port A and the associated LED using the breadboard and power from the trainer board. To prevent issues seeing the LEDs at certain angles, I've attached the keypad to SV2 using connectors rather than attaching it directly. I will first demonstrate that the key presses result in the desired output to the LEDs, and so I'll add my overlay and we'll begin. Here you can see that key 1 results in binary 1, key 2 results in binary 2, key 3 results in binary 3, key 4 in binary 4, key 5 in binary 5, key 6 in binary 6, key 7 in binary 7, key 8 in 8, key 9 in 9, key A in 10 or hex A, key B in 11 or hex B, key C in 12 or hex C, key D in 13 or hex D, asterisk in 14, pound sign in 15, and finally 0 in 0. From here, you should be able to demonstrate, as I am here, that subsequent key presses result in the desired output to the LEDs. Note that pressing the reset button during the demonstration should not yield a change in the desired behavior of the circuit. This concludes the demonstration of labs number 3 and 4. Please see the associated documentation for additional information and instructions.